So in this next group, we're going to actually do f of g of x. We had numbers in that first group, but now we're going to have an x here. This problem we've actually done once before, so I'm going to start with 14. So I'm going to do g of f of x. So what I'm going to do then is f of x is 3x plus 4. And this says to take 3x plus 4, plug it into the g function in place of the x. So that is going to look like 3x plus 4 squared plus 3x plus 4. So we're going to need to FOIL this out. So that's going to give us 9x squared plus 12x plus 12x. So it's going to be plus 24x plus 16. And then plus 3x plus 4. Combine like terms, we'll have 9x squared. We have 24x plus 3x is 27x. And then 16 plus 4 is 20. And that's going to be my simplified answer. All right, 15, we're going to do f of x. So we're going to do f, and then we're going to put f of x inside of our parentheses. So f of x then is 3x plus 4. So we're going to do f of 3x plus 4. So we're going to take 3x plus 4 and plug it into the f function this time. So it's going to be 3 times 3x plus 4 and then plus 4. That's going to give us 9x plus 12 plus 4 and combined terms, so it's 9x plus 16. All right, 16 and 17, we're going to use different functions. H of x is the absolute value of x, and m of x is 2x plus 5. So we want to find h of m of x, so h of m of x. So m of x then is 2x plus 5. So we're going to do h of 2x plus 5. So we take 2x plus 5, plug it into the h function, which is an absolute value. So I have absolute value, so I'll put this in there for the x, 2x plus 5. And there's nothing else we can do to it, so that's my answer. So m of h of x, so m of h of x. H of x is the absolute value of x. So I'm going to take the absolute value of x, place it into the m function in place of the x. So that's going to be 2 absolute value of x plus 5. And that's my answer. So you try number 18 and 19, stop the video, and give that a try. Okay, so moving over to 20 through 23, I think we'll take these and do these in class together as a group. So we'll just skip right on over to inverse functions next. So the inverse of a function is used often in higher level math. So in fact, we're going to be using it when we start our logarithm unit, the next unit. So we define logarithms as an inverse of an exponential function. So to find the inverse of a function for a set of ordered pairs, you just interchange the x and y. So let me just show you what that means. So if I have a function f, and it's defined with a set of ordered pairs, its inverse, which I'm going to write this way, is going to be equal to, and rather than 1, 0, I'm going to write 0, 1. So swap the x and the y. Then we'll do 7, negative 2, negative 6, 3, and 4, 4. And it's as easy as that for ordered pairs. So note that the symbol that I called f inverse, this symbol f inverse, is the single symbol used to denote the inverse of a function f. It is read as f inverse. So it's like using context when you're talking about in reading. Some words, look the same and sound the same, but they mean different in different contexts. So that's this way. So this does not mean an exponent of -1, which is 1 over an f. So that does not mean that. So when we're talking about functions, this symbol means f inverse. All right, so now we're going to find the inverse of a function, f of x. So to do that, we're going to replace f of x with the variable y. We're going to interchange the x and the y. We're going to solve the equation for y and then replace the y with the notation f inverse of x. So example 1, we're going to do this. So just imagine that this said f of x is equal to x plus 5. And then what we're going to do is we're going to replace the f of x with the variable y. So now I have y equals x plus 5. So in order to find the inverse, I'm going to swap the x and the y. So I'm going to get x is equal to y plus 5. Now I want to solve it for y, so I'm going to subtract the 5 and get x subtract 5 is equal to y. And then I'm going to replace my y with f inverse of x and say that that is equal to x minus 5. When I graph this original function, I have a y-intercept of 5 and a slope of 1, so up 1 over 1. So it looks something like this. And when I graph its inverse here, I have a minus 5, and again it still has a slope of 1, so it looks like this here. So I'm going to leave that here on hold for just a minute. Then example 3, we're going to look for its inverse. So again, pretend that that said f of x is equal to 1/3 x minus 8. And that in step 1, I replace my f of x with y. Then to find the inverse, I'm going to swap my x and my y and get x is equal to 1/3 y minus 8. Then I want to solve it, so I'm going to plus the 8. So I get x plus 8 is equal to 1/3 y. And then I need a y, so I'm going to multiply through everything by 3 and get 3x plus 8 is equal to y. So now I want to replace my y, this time with f inverse of x, and say that it is equal to 3x plus 8. Now, I would love to graph that, but both of these graphs go off the chart, so we can't do it. If you draw in the line y equals x on both of these graphs, you might observe that f and f inverse are mirror images of each other, and that the mirror is the line y equals to x. So the line y equals to x is this one here. And so you can kind of imagine if I flip that over, this goes over to that. And the same thing would happen if I could get those both on the graph there. We say that inverse functions are symmetric about the line y equals to x. And that's always going to be true no matter what your two functions are. They will be symmetric.